Hi everyone, today we are going to discuss CAN, Control Area Network. It is a communication protocol widely used in the automotive domain. Here we will be discussing about vehicle networking, need for CAN protocol, characteristics of CAN, types of frames, arbitration in CAN, and types of errors while transmission. Background. Why do we actually require vehicle networking? Earlier, we were using cars with mechanical parts only. As time moved, technology improved, and so do the user interfaces. Thus came the need of vehicle networking. What are the types of vehicle networking that are currently available in automotive domain? LIN, CAN, FlexRay, MOST. LIN means local area network, local area, local interconnect network. And MOST means media oriented system transport. You can see like in LIN, it follows the data rate of 20 kbps and MOST it follows the data rate of 24 mbps. These protocols exist in the vehicle according to their significance and the need for the data rate. Before CAN, we were actually following different topologies, one of which is this node topology. These topologies increase the cost of transmission and increase the complexity. CAN. CAN was a protocol that was developed by Bosch in the mid 1980s. It follows the international standard of ISO 11898. It is a message oriented transmission, not a node oriented transmission. That means, as we have seen in the previous slide, we have seen node oriented transmission where one node communicates with another node through a common node. But in message oriented transmission, it follows importance is given basically to a message, not onto the nodes. Asynchronous half duplex communication protocol. Asynchronous means no clock, and half duplex means either in transmission or reception happens. It doesn't happen simultaneously as in case of SPI or some other communication protocols. It is a multi-master, multi-slave protocol. That means there might be many masters M1, M2, M3, and there might be many slaves S1, S2, S3. They might be communicating to each other. Apart from automotive applications, CAN can be used in multiple number of applications, limitless number of applications. Like it can be applied to any other field. OSI model. It is a model used to represent any communication. It consists of higher end part such as the application layer, presentation layer, sessions layer, transport layer, network layer, etc. And the message authentication part such as data link layer. And the physical layer involves the message transmission such as wire, etc. This is basic CAN configuration. It consists of several CAN devices connected to a common bus. So here you might be having a question of why 120 ohm termination resistance. Those from the electrical background might know traveling wave concept where you terminate a resistance equal to the wire so you get minimum reflections, thereby noise is reduced. And 120 ohm, why 120 ohm? It is actually specified based on the ISO 11898 because the wire resistance will be approximately equal to 120 ohm. Now we move on to the number of frames that exist in CAN. Every communication protocol will be having a particular number of frames and a particular standard for each frames. Here we are having error frames, data frames, remote frames, interframes, and overload frames. This is basic frame format of a remote and a data frame. Remote frame actually requests for a data frame. We will discuss it in detail in the next slide. Here we can see every frame starts from a starter frame, which is actually a dominant bit. So you might be having a question, why dominant? Why starter frame starts with the dominant bit? Actually, the bus idle condition before this starter frame will be recessive. So, in order to identify whether the frame has start or not, you usually start with the dominant bit. That's why starter frame starts with the dominant bit. Then we have the message identifier used to identify the message priority. In that is the arbitration field. Actually, the identifier may be of 11 bits and 29 bits. If it is 11 bit, it's standard frame, and if it's 29 bit, it's extended CAN. Then we have the RTR bit. RTR bit 0 means data is included in the message. If it is 1 means it is a remote frame. And ID. Next one is the IDE, identifier extension bit. It indicates whether it's a standard CAN or a extended CAN. As in every communication protocol, each and every frames will be having some reserved bits, for further expansion of that protocol. R0 is a kind of reserved bit, reserved one. And DLC indicates the number of bytes of data which is being transferred. When you transmit a frame, receiver should understand that the frame will be having this much amount of data. This much amount of data will be coming. So every frame will be having a DLC. And next one comes the data field. Data can be 8 bytes or 64 bytes based on the CAN of D or the normal CAN. If it is CAN of D, it will be having 64 bytes. CRC. CRC, cyclic redundancy check, is an error checking mechanism just like a parity checking. CRC is the most advanced error checking mechanism when compared to the even parity or parity check, where you can check only single bit errors. In CRC, you will be calculating a CRC code based on some equations, and receiver side you will match it with that. If it is matching, no errors. The advantage of using CRC is you can detect multiple errors. Then we have that CRC delimiter with recessive bit. Then acknowledgement. Acknowledgement indicates whether the message is transmitted, is received or not. Then comes the ender frame, which is a 7-bit, that is recessive. This is basically a CANFT format with small changes in the normal data frame, such as the RTR has changed to double RS, and we have some other extra bits. RRS means remote request substitution. RRS means remote request substitution. Sorry, substitution. Then RRS ID is also already there. Then we have the reserved bit, FDF and R1. Then we have BRS. BRS is a bitrate switch. It indicates the speed of transmission, whether you have to transmit through 1 Mbps or 5 Mbps. Actually, the data rate is limited based on the length size. If you are transmitting 1 Mbps, you require a specific length. 5 Mbps, you can transmit up to only certain length. That's what limits the data rate. BRS indicates the data rate. ESI means the error status indicator. Rest everything is same as a standard. Arbitration in CAN. Arbitration indicates which node should communicate first. As discussed earlier, CAN is a bus network. Can follows the bus topology. So it will be connected to multiple number of nodes, node 1, node 2, node 3. So which node should communicate first? Every node will be trying to communicate with each other. So who wins there? Who is going to communicate? It is decided by this arbitration. Arbitration, actually dominant wins the arbitration. Dominant wins the arbitration. So you might be having a question, what is arbitration, right? So you go here, you check it out. You can check it from the figure, right? You have one here, one here, one here. You add three, you get one. You have zero here, one here, zero. You get zero. That means dominant wins the race. These are error and interframes. Interframe is just a frame space between two frames. This is basically an error frame. Error frame, there are two types of error frame. One is passive and active. So you might be having a question like what is passive and what is active, right? This is based on this error active and error passive is decided based on this REC and TEC counts. There are specific criteria which decides whether it remains in error active or in error passive. And this count is incremented based on a particular number of criterias, and it is incremented and decremented based on some errors, based on some particular criteria as per listed here. What are the types of errors that occur in CAN bus? Bit error. Bit error, it is a change in bit value, and CRC error, as we have discussed in CRC, cyclic redundancy check, change in CRC code received. Change. And form error is illegal bits detected, and acknowledgement error is illegal bits. And illegal bits. And acknowledgement error means you didn't get an acknowledgement for a data sent. And stuff error is like the bit time of the sixth consecutive equal bit level in the message field that should be coded by this method of bit stuffing. That means, 5 bits. After 5 bits, you should have another change in a bit. That means if you have five recessive bit, the sixth bit should be a dominant one. If you have a five uh, recessive bit, then sixth one should be dominant. If you have five dominant bit, the sixth one should be a recessive one. If it is not happening such, then we have the stuff error. Thank you. Hope to see you forward, and please don't forget to support us.